We're going to take a look at writing quadratic equations. Please make sure you're keeping up with your table of contents. So this is Unit 3, Part 3. As always, we're going to make some tabs. So go ahead and cart it to the margin and then cut it all the way down. And you're going to label it writing quadratic equations. All right, pause the video and copy this down, please. All right, so we're going to go ahead and take a look at all the different ways that you can write quadratic equations. So they can give you all kinds of questions. First one we're going to look at is what if they give you a pattern? So in this pattern, you see different things happening. So the question that you always want to ask yourself is, how is it growing? Okay, so how do I get from here to here to here? Now, there's lots of things that you can notice. There's lots of things that you can see. It just depends on what you visually imagine. Okay, so there is no right or wrong answer. It's just how do you see it growing? So for example, I see this 1 by 1 box over here, right, becomes a 2 by 2 box over there, and then becomes a 3 by 3 box over here, right? So I see this box right here is a 1 by 1 plus the 4 boxes that it has outside. Here we have a 2 by 2, right? Plus still the same 4 boxes we have outside. Here we have a 3 by 3 plus that 4 boxes we have outside, okay? So in reference to like each step, like this is step 1, step 2, step 3, or stage 1, 2, and 3, they have different names for it. I can see that it matches. Step 1 is a 1, step 2 is a 2, step 3 is a 3. So if I was to draw the next pattern, okay, so pause the video actually and go ahead and try to draw what the next pattern would be. All right, what I would see is, because I had a 1 by 1 here, 2 by 2 here, 3 by 3 here, I'm going to imagine that I will have a 4 by 4 here, and I would have that 4 boxes on the side. So what my imagination tells me is I'd have 1, 2, 3, 4, 1, 2, 3, 4. Okay, so 4 by 4, so I'm just filling in all the boxes. So a 4 by 4 box, and then on the outside, these random 4 boxes. All right, that's what I would imagine, okay? So if I was to draw step 5, I would imagine it being a 5 by 5 box plus those 4 boxes on the outside. So whatever pattern that you see, if you can figure out what does the next one look like. Well, here's the thing. In class, they're never going to ask you, hey, what's the next one? They're going to ask you, what's the 99th one? All right, so the key thing is to identify how is this pattern growing, so you can figure out some kind of equation, okay, as to how this is happening. So for example, what am I noticing? So it starts off with a 1 by 1 box, then you add 4. 2 by 2 box, then you add 4. 3 by 3 box, then you add 4. 4 by 4 box, then you add 4. What am I noticing here? That I'm multiplying the number by itself, right? And what do we call when we multiply the number by itself? You call it squaring. So what am I doing? I'm taking this step, I'm squaring it. So 1 squared is 1, and then I'm adding the 4 boxes on the side. 2 squared is 4, then I'm adding the 4 boxes on the side. 3 squared is 9, these are 9 boxes, then I'm adding the 4 boxes. 4 squared is 16, then I'm adding the 4 boxes. So if I was to sit here and count, 5 squared would be 25, and add 4 boxes would be 29. So I would actually draw in 29 boxes. So we're gonna go ahead and put that in words, okay? So what am I doing? I am taking each step, right, squaring it, and then adding 4 to it. Okay, so in words, what am I doing? I am taking each step, squaring it, and then adding 4 to it. Okay, so let's take a look at how do I write that down in terms of an equation. So whenever you see patterns, they're going to use n. And n is just the term. So this is the first one, the second one, the third one. That n represents 1, 2, 3, 4, 5, 6, and so forth. So I'm taking the first term, I'm squaring it, right, which means that, then add in 4. So this is going to be how I discover my 50th term, for example. All right. If I needed to represent that same pattern in this table, notice it says stage 1, 2, 3. So the next one would be 4. The next one would be 5. All right. The number of boxes, if you count 1, 2, 3, 4, 5. Number of boxes here, 8. Number of boxes here, 13. Number of boxes here, okay? So like we said, because I don't feel like counting, 4 squared is 16 plus 4 is 20. All right, 5 squared is 25 plus 4 is 29. And again, if I sat here and count every single box, I would get 20 boxes. And you want to double check your formula to make sure that it matches the number of boxes, that it works for every single thing. So for example, in stage 1, when n is 1, 1 squared, okay, is 1 plus 4 is 5. Do I have 5 boxes in the first one? 1, 2, 3, 4, 5. Yes. And you want to check at least 3 because sometimes it works for the first one and not for the rest. All right. So that's the pattern that's happening there, okay? So in terms of quadratic functions, what's always true is this. We're going to take a look at this table, okay? From stage to stage, we notice that it is constantly changing by the number 1. So to get from 1 to 2, I add 1. To get to 2 to 3, I add 1. To get a 3 to 4, I add 1. To get a 4 to 5, you add 1. Okay, so I notice that my stages are changing by adding 1. Let's take a look at what happens to my number of boxes as my stages are changing. So from 5 to 8, I would add 3. From 8 to 13, I would add 5. From 13 to 20, I'm adding 7. From 20 to 29, I'm adding 9. So it's not changing constantly like it did on X, but what happens if I do it again? So if I did, how did I change from 3 to 5? I added 2. How do I change from 5 to 7? I added 2. How do I change from 7 to 9? I add 2. So what do you notice now? The second time I do it, the change is constant, okay? And this is always true about quadratic functions, okay? So what is always true about quadratic functions? The x value grows at a constant rate. And the second difference, that means the second time that I find out the difference between each number, okay, the second difference of the y value also grows at a constant rate. All right, so this is a very, very, very important thing. So the x value grows at a constant rate, and so does the second time I do the difference between each number for the y value, okay? So for it to be quadratic, the second difference must be constant, and the x value also must be constant, all right? So if they give you a pattern, you just look at the pattern and figure out what's happening in each one. All right, what if they gave you a sequence, okay? So a sequence is just numbers like 2, 6, 12, 20, 30. There's a sequence. So consider this sequence, okay? Now, it's the same idea. So it's the same thing as them telling you it's the number of boxes. So here it would have been 5, 8, 13, 20, 29. That would have been the sequence. So now there's no visual representation. However, you can still figure out what is happening and be able to tell me what the 50th number would be if we needed to know what the 50th number would be. All right, so let's look at the term. So the term represents, just like it did in the boxes, the number. So this is stage 1, step 2, step 3, stage 4. Okay, and you can use step, stage, however you want to say it. So the first term, the second term. So the first term is 2. The second term is 6. The third term is 12. The fourth term is 20. The fifth term is 30. And I'm going to figure out how is this pattern changing each time. And so you can sit here and again, because this is quadratics, I know that I can kind of cheat through it. Because it's quadratic, I know the second difference is going to be constant, but I'm going to just double check and make sure. So how do I go from 2 to 6? I add 4. How do I go from 6 to 12? I add 6. How do I go from 12 to 20? I add 8. How do I go from 20 to 30? I add 10. All right, so you can see there's no constant rate. However, here, I add 1. From 2 to 3, I add 1. From 3 to 4, I add 1. From 4 to 5, I add 1. From 5 to 6, I add 1. So that's constant. This isn't constant, okay? But what if I do it one more time? From 4 to 6, I add 2. 6 to 8, I add 2. 8 to 10, I add 2. And you can see the second time, so this is the first time I do it. This is the second time I do it. It's constant. So we know from quadratics that it is a quadratic function if the x value grows at a constant rate, plus 1, and the second difference of the y value also grows at a constant rate. Now, it just so happens that in this example, it was 2, but it doesn't have to be 2. And even here, it doesn't have to be 1. As long as whatever number it is, it's the same throughout the whole time. All right, so now I know that for sure this is quadratic. Now, I don't have a picture to see, oh, the boxes is a 1 by 1, or a 2 by 2, and a 3 by 3. So how do I figure this out? Well, if I know that it's quadratic, I can already tell you that something is going to be squared, okay? So what I'm going to do is we're going to take the term, so the first term, all right? And just like before, we knew, like, hey, take this one and then square it, right? Take 1 and then square it. Take 2, then square it. Then 3, then square it. 4, then square it. All right, we're going to do the same kind of idea here. So we're going to take the term 1 and then square it. 2 and then square it. 3 and then square it, 4, square it, 5, square it, 6, square it. Now I'm going to write down what those answers are because I'm trying to get to this number and I don't know exactly what I need to do. So in this previous example, it was I squared and I add 4, right? But it could be anything in any kind of example. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. All right, now I need to ask myself, okay, so I know I'm squaring something. How would I go from 1 to 2? Okay, I would add 1, right? And this doesn't necessarily mean that this is the right way. You just have to find out what the pattern is. How do I get from 4 to 6? I would add 2. How do I get from 9 to 12? I would add 3. How do I get from 16 to 20? I would add 4. How do I get from 25 to 30? I would add 5. And since I don't have a number here, I don't know what that is, so I'm just going to leave plus. All right, what am I noticing about this number? They're not the same. So unlike before, where I was just squaring it and adding the 4 boxes on the outside, I can see that I'm not adding 4. I'm not even adding the same number. So what can I notice about these numbers? This is 1, 2, 3, 4, 5. Where can I see those numbers? I see those right here, right? 1, 2, 3, 4, 5. All right, so that means, because remember term is n, right? That means that each time I take the term, right? So I start off with 1, I square it, and then I add it to itself. Okay, so what I'm saying is I take the term, I square it, and then I add it to itself. All right, so check this out. So I take the term, so 2, I square it, which is 4, and then add the term again, which is 2, which is 6, and I get 6. Take the term, 3, square it, 9, plus the term again, which is 12. Same thing, 4 squared, which is 16, plus 4 is 20. 5 squared, plus 5 is 30. 6 squared, 36, plus 6 is 42. And so now I know what my 6th value is. Now my question can be, hey, what is my 12th value? Once you figure out the pattern of how it's going and you're able to write down the equation, all you do is you plug it in. So what is my 12th value? Well, n represents the term, right? So if n is 12, that's what this question is asking. When n is 12, all you do is substitute where you see n, you're going to put the number 12. So it's 12 squared plus 12. So you're going to get 144 plus 12, which is 156. Okay, so once you figure out the pattern, you are able to figure out what is the 12th term, what is the 100th term, what is the 1000th term, so no matter what it is. So whether they give you a picture or they give you a sequence, it doesn't matter. You figure out the equation and then you can answer whatever question they want to do with that. All right, so let's try another one, all right? So these take a second to see because it's not a visual representation. Let's see if we can figure it out. So the first term is 2. And right on the left-hand side so that you can have time to check if it's quadratic. Second term is 8. Third term is 18. Fourth term is 32. Fifth term is 50. and I don't know what my sixth term is. I'm going to figure it out. So first thing I'm going to check to see is this a quadratic equation? Because if it's a quadratic, it's giving me, I'm already going to know it's something squared. So I can start squaring something and see if it gives me the term values. All right, so let me check if it's quadratic. So you check the differences. So in terms of the x, as long as it's growing at a constant rate, so this one, you add in 1 each time. Okay, so that's constant. And then remember, once again, both the x value grows at a constant rate and the y value, second difference, is a constant rate. All right, so the first one from 2 to 8 is plus 6, 8 to 18 plus 10, 18 to 32 plus 14, 32 to 50 plus 18. Okay, and if you can't do that in your head, all you have to do is do 8 minus 2 is 6, 18 minus 8, 10, 32 minus 18, 14, 50 minus 32, 18. All right, now let's check the second difference. From 6 to 10, I'm adding 4. See, this time it's not 2, and it doesn't matter as long as it's constant. From 10 to 14, I'm adding 4. From 14 to 18, I'm adding 4. So we can see again, it is the second difference. So this is a quadratic, okay? Now that I know it's a quadratic, I know I'm going to take it and square it, okay? So I start off with my term. So this is my first term, square it. Second term, square it. And I'm just messing around with it to see which one's going to give me this number. Fifth term, square it. Okay. Let me write those numbers down so I can see how far I am from the actual numbers I need. So this is 1, 4, 9, 16, 25. All right. From 1 to 2, okay, what would I need to do? Maybe add 1, okay? And again, you see how light I'm writing? Because I don't know exactly what the pattern is. So I'm going to have to sit here and figure some stuff out. From 4 to 8, I'm adding 4, right? From 9 to 18, I'm adding 9. From 16 to 32, I'm going to add 9. From 25 to 50, I'm adding 25. All right, so I can see again, it's not a constant number, right? So I can't say, oh, it's n squared plus a number, because that won't work. I can't say like before that, actually this looks like it could be kind of like before actually. So I can't say like before that it's adding n, because that's n, but this is an n. This looks like it's n, so this is an n. But what do I notice about these numbers? This is 1, 2 and 4, 3 and 9, 4 and 9, 5 and 25. What do I notice about those numbers? Like, how can I get from the term to those numbers? Isn't it twice this number? So one time, no, it's not twice the number, because 1 times 1 is 2. So even though twice 2 is 4, twice 3 is not 9, so that doesn't work. Okay, how about n? So the first one is n squared, right? And if I said that this one was n, okay, so n is 1, n is 2, so this would have to be 2. So that doesn't work either. But what if I said, how about if we squared n? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Oh, I'm sorry, I made a mistake that was 16. 16 plus 16 is 32. 5 squared is 25, so that works. So n squared plus n squared would be my equation, and I can simplify that further, because if I have 2 apples plus 2 apples, then it's going to give me 4 apples, right? So it's the same thing here. So I have 1 apple plus 1 apple, and that's going to give me 2 apples. So I have 2n squared. So that's my equation, 2n squared, or I can leave it as n squared plus n squared. All right, so what would be my 8th term? So let me figure out what my 6th term is. Now, if I still wasn't able to figure out this pattern, okay, what I could always do is do it, like I could find my 6th, my 7th, my 8th. But if they ask me for the 100th, I definitely have to know this equation. So if I know that it's changing plus 4 each time over here, I know that from here to here, I have to add 4, right? It has to, sorry, something plus something has to have changed by 4. So this number has to be 22. Because 18 plus 4 would have given me 22, which means when I come back here, some number plus something has to be a difference of 22. So this number would have had to be 72. Okay, now I'm going to check it with my equation. Okay, so it says n, which is 6, squared is 36, times 2, which is 72. So that I know that one's right. So if I had to find the 8th term, I'm sorry. n is equal to 8. Find it when n is equal to 8. All I do is put 8 where n is, so 2, 8 squared. So I have 8 squared, which is going to be 64, times 2, which is 128. So you don't have to sit here and keep doing all of this math to get to whatever term they want. If you can find the general equation, then you can find the 8th term.